Hey, I got your beautiful apartment building right over here. And this individual, this giraffe, has preferences over the set of the units in this apartment building. He prefers a unit with 5 rooms on floor 12. There it is on floor 12. It's got 5 rooms. Prefers this unit to one with 4 rooms on floor 20. So he likes this one better than that one. And he prefers one with 4 rooms on floor 5 to one with 2 rooms on floor 12. All right, we got a bunch of these things that he prefers. Okay, we know some of the things that he prefers. And we're asked to show that this individual's preferences are consistent with some preference relation. So come up with the preference relation that explains, or that is consistent with these preferences, with these individual preferences. All right, so let's write this as the following. All right, so we have 2 characteristics of each good or bundle. We have the number of rooms and we have its floor. So let's state this as a vector, or a list of 2 elements, with the first element representing the floor. No, the first element representing the number of rooms and the second element representing the floor. Okay, it might be that this is a problem that I might face in business. I'm trying to decide how to price different apartments. I want to model individuals, have some data on what apartments people chose or what people looked at instead of others. And I might want to find some way of modeling their preferences, and what would be a convenient way of modeling their preferences that wouldn't really be missing out some important facts. Okay. But we're doing this a lot more formally than you would do in any practical problem. Okay, so we're going to say number of rooms and then floor, how high it is. So we have 5 and 12. So this bundle, this apartment with 5 and 12, it's been stated that he prefers it to 4. Sorry, I don't want to write it like that. He prefers it to 4 rooms on floor 20. He also prefers 4 rooms on floor 5 to 2 rooms on floor 12. We're letting him have whatever preferences he wanted. We're not judging. He just happens to have these preferences. Okay. And 2 rooms on floor 20 is preferred to 5 rooms on floor 5. And what else? I guess those are the only 3 things we know about his preferences. Okay, we want to find some way of characterizing these preferences maybe in a simpler way. A preference relation. Okay, so how could we characterize it? Well, we can think about the rooms. Well, they call it the rooms and L for floor. I don't know why L. Okay, I'm just using the notation given here. Okay, so it turns out, well, hold on, before I say it turns out, how do I come to this? How do I make some sense out of this? Okay, and by the way, I didn't ask you to do this problem. I just want to do it to get started to get our minds around this thing. Okay, so let's see, what seems to be going on here? What can I think about these three preference judgments, whatever you want to call them? Well, So what could characterize his preferences? Well, it seems like, okay, here he prefers the thing with more rooms to the thing with fewer rooms. Here he also prefers the thing with more rooms to the thing with fewer rooms. So maybe, but here he prefers the thing with fewer rooms to the thing with more rooms. Okay, but can I say that he wants to be as high as possible? No, that doesn't seem to be the case. Here he prefers to be lower than to be higher. Okay, what else? How else could we characterize this? Could it be that he just doesn't want to be on floor 5, but otherwise he wants as many rooms as possible? Well, no, that's not true, because here he's willing to give up having more rooms. Here he prefers. Well, okay. Here he prefers being on floor 5, so it's certainly that it's not that being on floor 5 is somehow is something that he never wants to do. Here he prefers 4 rooms on floor 5 to 2 rooms on floor 12. All right. Well, let's think about this. Okay. I mean, this may not be the most convenient way to summarize it. Maybe he just doesn't like this particular combination. He doesn't want to have 5 rooms on floor 5. You know, it seems like a little irrational, or not irrational, but we can't ascribe irrationality to people's actual preferences. There's nothing intransitive here, and, you know, maybe the combination matters in ways we don't understand. Suppose he just doesn't want to have 5 rooms on floor 5, or I could have said he doesn't want to have more than 4 rooms on floor 5. That would be another way of characterizing it. You see, we haven't really pinned out exactly what's driving these preferences. We just know certain things are preferred to others. Okay, so one thing I could say is that if he prefers things with more rooms over things with fewer rooms, unless the thing with more rooms has exactly 5 rooms and is on floor 5. That's a bit weird, but, you know, maybe there's something bad about having too many rooms on floor 5. I don't know. Okay, fine. So how would we write that formally? We could say something with number of rooms R on floor L is weakly preferred to, I could also say strictly preferred, but I guess what I'm about to define will also imply the strict preference here. But actually, I'm just asked to show that it's consistent with a preference relation. So when we talk about the primal preference relation, we express things in terms of weak preferences. So an apartment with some number of rooms and some number of floors is preferred to some other apartment, which we call R prime, which with characteristics R prime, L prime, R prime number of rooms, L prime number of floors. If and only if, okay, either, so I could also say the arrow goes in both directions. That's the if and only if. So if one or both of the following hold, that's the one, the number of rooms is greater, so R greater than or equal to R prime. Or we just happen to strictly be in it, or we're in a unit with 5 rooms, or in other words, or the second, the thing that we're comparing it to has exactly 5 rooms and 5 floors. And is on floor 5. Okay, so an element is at least as good as another element, or a bundle or apartment is at least as good as another element if it has at least as many floors, or if the second element happens to have 5 floors and be on floor, 5 rooms and be on floor 5. So if it has more, at least many greater than, it has more or the same amount of rooms is at least as good. Note that if it actually has more rooms, then the reverse will not hold. So we will not have the reverse direction of this, therefore it'll be a strict preference. So if either it has more rooms or the thing we're comparing it to has exactly 5 rooms and is on floor 5. Okay, I could have also said, or the thing we're comparing it to has the same number of rooms as floors. That would be another preference that would agree with this. Or I could have said has, etc. More than 5 is on floor 5 and has more than 5 or more rooms. Okay. Now, what kind of or is this here? Well, let's see. If both are true, are we talking about a case? What if have I said this correctly? Is this the inclusive or? Okay. If it has more, so suppose it were the inclusive or. Does that agree with it? So if it has more rooms, or the second one is 5, 5, then it is preferred. Okay. But what about the case where it has more rooms and the second one is 5, 5? Well, we don't have an example, so we don't know. We don't have an example where it has more rooms and the second one is 5, 5. There's no particular preference that would allow us to distinguish. This could either be inclusive or exclusive or. Okay, so let me break it up and I'll do the next part, the part that I actually asked you to do.